These notes are for January 18th, January 19th, unless you're in 3B or 4B. Then we covered actually law. Today we're going to look at is law of sines. If you're in 3B or 4B, you're going to need to look at this set of notes and the next set of notes because we covered those all in one day. Only if you're in 3B or 4B. But here we're going to talk about what we call the law of sines. It sounds like a big daunting thing, but hopefully we see that it won't be too bad. And we'll see how we use it. But in class, what we did is talk about these first two triangles and trying to solve for x. And what we talked about here in this first triangle is, here we're given an angle. We know it's a right triangle. We have the side opposite and the hypotenuse. And so what we said is we can solve for x by saying this is sine of 67 degrees. That would equal 24 over x, opposite over hypotenuse, using, SOHCAHTOA. And now we can solve for x. So we can solve for x here by multiplying both sides by x. There's a lot of ways you could do it, but this is the one way we did it in class. If we do that, then you'll have x times sine of 67 degrees. These x's would go away. We would have 24. And then we can divide by sine of 67. Those would go away, and what we would end up with is that x is equal to 24 over sine of 67 degrees. Now, if we don't have a graphing or scientific calculator, this is as far as we can simplify this. If we did have a graphing or scientific calculator, then we could put that in the calculator and actually get the correct value. But on a challenge exam, the exam you'll take at the end of the year, I'm pretty sure this is the final solution that they would want. So we did this last semester using right triangle, we call right triangle trigonometry, to help solve triangles. Similar thing here, we were trying to find this angle. Then what we have here is the adjacent side and the hypotenuse. And so again, we're looking at adjacent and hypotenuse. What we could say is cosine of x. Excuse that.
Very quickly, the seniors that are going to the American Baptist College conference today with Ms. Gibbs and Mr. Valley, we'll be dismissing those students at 9:20. My apologies, we thought the bus was here at 9, but our bus shows up at 9:30. The bus will be here at 9:30, so we'll dismiss at 9:20. Thank you.
Now, what we need to think about is, and we talked about this at length in class, and we'll talk about it at length here, if not in this video, the next one. Now we want to get x alone. Now we can't divide by just cosine. Here, it's sine of 67. That's an actual value. That's an actual number. If you type that in the calculator, you get an actual value. But if you hit cosine in the calculator, it would be like this, meaning you need a number to get the value. So we can't divide by just cosine. Now, we want to get the cosine away from x, and the way we do that is by using what we call arc cosine. We did this last semester, and what we would say is that x equals arc cosine of 109 over 134. Or, an equivalent way to write this is cosine inverse of 109 over 134. All right. Now, we had a discussion about this triangle. We're given two angles, this side and x. We want to solve for x. And the question was, what can we do to help solve for x? And here, the ultimate conclusion we made is that these two triangles are right triangles. So if we have right triangles, we can do SOHCAHTOA, right? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Because sine, cosine, and tangent, those are functions that are derived from the ratio of right triangle sides. Here we don't have a right triangle. So we can't say sine of 29 degrees equals 11 over x. That's not true because it's not a right triangle. So the idea being, hopefully we can develop or talk about new ways, new things that we could use to help solve these triangles that are not right triangles. And we can. We're not going to develop this. I'm just going to give it to you. If we wanted to develop it, we could, but it would take a lot of time, so we didn't do that. And it's called the law of sines. So we're given really any triangle. It could be a right triangle, non-right triangle. It's real obviously more helpful if it's a non-right triangle. Then we would label the sides and angles. All of your angles are going to be capital letters. Okay? All your sides are going to be lowercase letters. Also notice that if big A is here, the side opposite of it is little a. Big C is here, the side opposite is little c. Big B, little b. And it doesn't matter how we label the sides. For example, if we were given a problem that has the sides labeled like this, if it helps you see it, if it helps you determine other angles or sides, we could relabel this. We could call this A, this B, or C, this B. It does not matter how we label the triangle. What matters is your angle is opposite, like the big B is opposite little b, big A is opposite little a, big C is opposite little c. Okay, that's what matters here. Now, as long as we have these triangles, what the law of sines says is that sine of big A over little a is equal to sine of big B over little b, which is equal to sine of big C over little c. And essentially what's happening here is we can choose any two. You're not going to use all three at the same time. We can choose any two, meaning we can say, hey, if we're given A's and the C's, we can ignore the B part and say sine of A over A is equal to sine of C over C. If we're given the B's and the C's, we can ignore the A part. If we're given the A's and the B's, we can ignore the C part. That's what this equation is saying. That's what this law is saying. All right. Now, we're going to see how to use it. We'll probably go over 2 or 3 on the back side. We'll let you work on the rest of them. So watch the next video to see how we actually use the law of sines to find different angles and sides.